Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 2, Lesson 7 on solving equations with unspecified constants. That's a mouthful, right? But the idea is that normally when we're solving linear equations or other types of equations, there's sort of one variable, if you will, right? It's x, it's n, it's t, it's r, or whatnot. And we solve it, and when we're working with the actual numbers that are present in the equation, we're combining them, we're adding them, dividing them, subtracting them, etc. In today's lesson, the equations that we're going to be working with not only have that variable that we're trying to solve for, but they have other things, letters that is, that actually stand for numbers that we don't know yet. You could think of those letters as unspecified constants, in other words, like values that we just haven't told you yet, or you could even think about them as other variables. It doesn't really matter, right? The important thing today is that we want to extend what we've been doing with equations so that we can solve them in a more general way. Let's launch right into it so that you understand what I'm getting at. All right, here we go. Solving equations with unspecified constants. There are times when we will need to be able to solve equations or rearrange formulas that contain constants that are unspecified. Their values are not told to you. It is important to be able to isolate whatever variable you're interested in. In other words, to get it all by itself on one side of the equation. Let's take a look at a simple example in exercise number 1. Solve each of the following problems for the value of x. In B, write your answer in terms of the unspecified constants a, b, and c. All right, great. There should be no need for me to go through how to solve letter A. What I'd like you to do is pause the video now and solve letter A, and then we're going to go through letter B in exactly the same way. Pause the video now. All right, well, I know that letter A is only a two-step equation, 5x plus 3 equals 33, but I do want you to be thinking always about that idea of using inverses to isolate a variable. In other words, right, x in this equation has been multiplied by 5 and then had 3 added to it, and the result is 33. So when I solve it, obviously, what I'm going to do is I'm going to subtract 3 from both sides, and I'm going to get 5x is equal to 33 minus 3, which is 30. And now I'm going to divide by 5 on both sides. And of course, 30 divided by 5 is equal to 6. Now I would claim that the equation in B, which is a times x plus b equals c, I would claim that that equation is identical in structure to this one. In other words, if I want to think about what's happened to x here, I've taken x, I've multiplied it by a, I've added b to it, and the result is c. So together, let's actually go through solving this equation for x. We're going to do it in exactly the same way, right? I'm going to undo what's been done to x in the opposite order. So the first thing I'm going to do is subtract a b from both sides. Now, in the previous problem, I had 33 minus 3. Here, I simply have c minus b. And I'm going to pause just for a moment here, right? Again, in a normal problem, I'd say, well, 33 minus 3 is 30. The best I can do in this problem is say c minus b is c minus b. That's it. There's just nothing else I can do, right? But now, I want to take this equation and I want to get rid of the multiplication by a. So I'm going to divide both sides by a, and I have to divide that entire side by a, and I get x equals c minus b divided by a. Again, in the last problem, I was able to take that 30, divide it by 5, and get a final result, which was 6. In this problem, the best I can do is take that c minus b, divide it by a, and leave it that way. But the cool thing about having a formula like this is that now, if I gave you any equation, right, that had this form, I could have like 7x plus 1 equals 22, I could put those values in for c, b, and a, and immediately crank out what x was equal to. All right, so that's all I'm doing. I'm following exactly the same algebraic procedure I did here, except in these situations, I can't figure out what c minus b is, and I can't figure out what c minus b divided by a is because I don't know the values of those three constants. They are unspecified. I have not told you what they are. So let's kind of keep working at this. Everything that you've done, right, leads you up to this point. But it's really good when you're trying to first work with these types of equations, it's good to first try to solve one that is familiar, right, with normal numbers, and then extend that to a problem where you've got all these unspecified constants, just like we did in the last problem. So let's do that again in exercise number 2. Solve the following two equations. In letter B, leave your answer in terms of the constants a, b, c, and d. Awesome. So what I'd like you to do is take a moment. I want you to think about order of operations, what's been done to x in this problem, all right, and then undo it in the reverse order to isolate x. Once you do that, we'll go through it, and then I'm going to have you work on this one, which has the identical structure to it that this one does. Pause the video now and just work through letter A. Okay, in this particular equation, we have x plus 5 divided by 2 minus 7 is equal to 3, right? So I've added 5, divided by 2, and subtracted 7. So I'm going to add 7, multiply by 2, and subtract 5 to isolate the x. Here we go. Add 7 to both sides, right? Those cancel. I get x plus 5 divided by 2 is equal to 10. Multiply by 2 on both sides. That cancels. I get x plus 5 is equal to 10 times 2, which is 20. Now I'll subtract 5, and I'll get x is equal to 20 minus 5, which is 15. Okay, so now what you want to do is literally look at this equation, right? They have exactly the same structures, right, in this equation. I've added a to x, I've divided that result by b, and then I've subtracted c, and my result is equal to d. I want to now reverse all of that, right, by adding c, multiplying by b, and subtracting a to get a final answer. Pause the video now and see if you can figure out what x is equal to in terms of all those other unspecified constants. Okay, great. So what I'm going to do, right, just like I did in letter A, is I'm going to begin by adding c to both sides. That's going to leave me with x plus a divided by b is equal to d plus c. Now, it is wise at this point to put a parentheses around the d plus c. All right? It's wise to do that because if I end up either multiplying or dividing that side of the equation now, I have to do it to the entire side. If I don't have parentheses around that d plus c, I might end up multiplying or dividing only one of those two constants, right? So I want to have those parentheses there. All right, let's keep going, right? We're now at this step, right? Look at the identical step. And what did I do here? I multiplied both sides by the number 2. Here, I'm going to multiply both sides by b. And I'm going to cancel. Now, there is a really good question at this point whether or not I should distribute the b through that parentheses or whether I should just leave it like this. And I'm going to move that b to the front. That's typically where it's sitting. I could certainly multiply the b through the parentheses and I'd get b times d plus b times c. But there's really no reason to. There's nothing in this problem that says I've got to somehow leave it so that there's no parentheses in the final answer. All I have to do is get the x all by itself. So the final thing I have to do is I need to just simply subtract a from both sides. That cancels, and I get x equals b times d plus c minus a. There certainly would be absolutely nothing wrong with multiplying through by the b, but you certainly don't have to. All right, so that's it. Again, very critical to have the parentheses around the d plus c. If you don't have them there, right, and you just have like maybe b times d plus c minus a, right, that's incorrect. Got to get those parentheses there. All right, Now, we can certainly, right, have situations where there are both variables and numbers and unknown constants in an equation, all right? Don't ever forget, though, that our main technique, and we've been emphasizing this throughout the last couple lessons plus today, our main technique in isolating any variable is reversing the operations that have been done to it in the opposite order. So let's take a look at a nice multiple choice problem that mixes numbers, variables, and unknown constants. Exercise number 3. When 2 times the quantity x minus h plus k is equal to 8 is solved for x in terms of h and k, its solution is which of the following? Show the algebraic manipulations you used to get your answer. Okay, great. What I'd like you to do is I'd like you to take this equation. I want you to think really hard about what's been done to the variable x, okay? In terms of the numbers 2 and 8 and then h and k and all of that. And I want you to rearrange that formula to get x all by itself. Pause the video now and play around with the algebraic manipulations. All right, well, let me write down the equation, then we'll talk about the operations and how to solve for x. Here we go. All right, I've got my 2 times x minus h plus k is equal to 8. All right, so we should be able to predict exactly what we need to do to get x all by itself, right? Think about this. I've subtracted h, I've multiplied by 2, and I've added k. So to get h all by itself, I'm going to have to subtract k, divide by 2, and then add h to both sides. So let's do that. Here we go. I'm going to subtract k. Now the best I can do at that point, is write this as 8 minus k. Not much I can do about that. I'm going to divide both sides by 2. Make sure to get that 2 under both the 8 and the minus k. And I'll get x minus 8 is equal to 8h equals 8 minus k divided by 2. Maybe give myself a little bit more room. I'm going to add h to both sides. And I'll get x is equal to 8 minus k divided by 2 plus h. All right. I'm going to bring that right up here so that I can see it a little bit better. Now, that's the correct answer. And if we had a free response problem and I said, hey, solve for x in terms of h and k, and you left it like that, thumbs up. The problem is when we look at our 4 choices, none of them are, at least on first glance, equal to that answer. And the reason for that is because the division by 2 has been distributed in all 4 of these answers. So we need to take it a little bit further, right? In fact, what I'm going to now do is I'm going to say this is 8 divided by 2 minus k divided by 2 plus h. Of course, 8 divided by 2 we can do something with. That's 4 minus k divided by 2 plus h. Now that's a lot closer, right? That's a lot closer to what I had before. 4 minus k divided by 2 plus h. That almost looks like some of these, right? The one that it's actually equal to is choice 2, right? And it's equal to choice 2 because I can use the commutative property of addition to swing this 4 plus h around to let that h be at the beginning and eventually have h plus 4 minus k divided by 2. One of the tricky things about multiple choice problems, obviously, is that you always have to get the answer, or you have to be able to recognize your answer in one of the 4 choices that you're given, all right? And even though we maybe did everything correct to get to here, we still had to go a little bit further by distributing the division by 2, and then by rearranging our final answer so that it looks like the choice that's sitting right there. All right, let's get a little more work on this. These types of problems can be very, very challenging for students. And a lot of students might say, you know, I just can't believe I am ever going to have to use this ever. But we do have to use this skill quite a bit in science and engineering when we have a formula that involves multiple variables that we want to rearrange to highlight or isolate a particular variable of interest. So let's take a look at that, right? That's one of the most common things that we do in that. And a great example of it is to work with the perimeter formula for a rectangle. Let's take a look at exercise number 4. For a rectangle, the perimeter P can be found if the two dimensions of length L and width W are known using the formula P equals 2W plus 2L. Letter A asks us to rearrange this formula so that it is solved for the width W. Show the steps that you use to manipulate the formula. All right, so in other words, right now this formula will calculate the perimeter if I plug in values of the width and the length. What I'd like to do is rearrange the formula so that instead of it being a formula for perimeter, it's a formula for width. In other words, the width is all by itself. So I'd like you to pause the video and see if you can get the W all by itself. Take a moment. All right, well, the first thing I want to mention is that equality is symmetric. So if you're bothered by the fact that the W is sort of sitting on the right, one thing that you can begin with is you can begin by rewriting this equation as 2W plus 2L is equal to P. That is often helpful for students when the variable that they're trying to isolate is on the left side of the equation. Now let's think about what's been done to W. I've taken W and I've multiplied it by 2, and then I've added this thing to it. Notice how I said that? This thing. You know, it's 2 times W plus this thing. All right? That thing is 2 times L, but that doesn't really matter. It's 2 times W plus something equals something, right? So to undo that, I have to subtract this thing from this thing, and then I have to divide by 2. All right? So the first thing I'm going to do to get my W all by itself is I'm going to subtract 2L from both sides. That's going to give me 2W is equal to P minus 2 times the length. And now I'm going to divide by 2 on both sides. Remember to get that 2 underneath the entire fraction. And I'm going to get W equals P minus 2L divided by 2. You could, if you wanted to, distribute the division by 2. There's nothing wrong with that. If you did do that, what you'd end up having is you'd end up having P divided by 2 minus L, right? Because 2L divided by L would be just L. But either one of these would be okay, whichever one you find easier to use. They're both great formulas that will calculate the width if you know both the perimeter and the length. And in fact, let's do that, right? In letter B, it says a garden has a perimeter of 244 feet with a length of 85 feet. Use your formula in A to find the width of the garden and its area. Use proper units for both. All right, well, pause the video now and see what you can find out for your width. All right, well, here we go, right? We've got ourselves a formula, right? Our width is equal to our perimeter minus twice our length divided by 2. We're told that our perimeter is 244. We're told that our length is 85, all divided by 2, right? We've got 244 minus 170, all divided by 2. 244, I got to do a little mental arithmetic because I don't have my calculator up right now. 244 minus 170 is going to be 74 divided by 2, and that's going to be 37. And of course, that's 37 feet because both the width and the perimeter are in feet, right? So then, both the perimeter and the length are in feet, so the width must be in feet as well. All right, the area, of course, is just equal to the length times the width, which is then 85 times 37. I don't have my calculator up right now, so we could do this sort of the long way. And what would that be? 85 times 37. Let's do a little multiplication here. 5, 35, 56, 59, 0, 15, 24, 25. Nothing like a little bit of A little bit of long multiplication early in the morning, and we've got 3,145 square feet. All right, so one of the big things that you use this skill for in engineering and science is to be able to take a formula, that's been devised for whatever, the volume for a cone, the area for a circle, right? Anything like that, and rearrange those formulas so that you're solving for a particular variable in the formula. Let's keep working with this. Now, there are some trickier problems, right? Solving when there are only letters. Now, this is very typically the most challenging situations in these types of problems. So we're going to kind of go back to what we did before, and we're going to take a look at one of these problems where there's numbers present, right? That's going to be letter A. Then we're going to take a look at one where it's just all letters. So let's take a look at exercise number 5. Consider the equation a times x plus b equals c times x plus d. We would like to solve this equation for x. First, we will start with the situation where we know the values of a, b, c, and d. All right, so what I'd like you to do is pause the video now and solve letter A all on your own. That should be a piece of cake. Take a moment to do that. All right, well, you could do this in a variety of different ways. What I'm going to do is I'm going to actually get all the numbers on one side first. So I'm going to take this equation and I'm going to subtract 1 from both sides. And that's going to give me 8x equals 5x plus 21. I'm then going to subtract a 5x from both sides. And I'm going to get 8x minus 5x is 3x, and that's equal to 21. And then I'm going to divide by 3 on both sides, and I'm going to get x equals 7. Now, we should be able to solve the equation in letter B, the one that we're actually interested in, by literally doing each one of these steps, which is going to be a little trickier because of all the letters involved. So watch what we're going to do. We're going to kind of go back and forth between the board and me as I kind of walk you through this process the first time, sort of slowly. All right, so the first thing that we did in letter A is we subtracted 1 from both sides. First thing I'm going to do in this problem is I'm going to subtract b from both sides, okay? And when I do that, I have ax is equal to cx plus d minus b. Again, keep in mind that in this previous problem, I was able to do 22 minus 1 and get 21. The best I can do here is do d minus b and be left with d minus b, right? That's all I can do. Now, in our next step over here, I subtracted 5x from both sides. In this case, I'm going to subtract c times x from both sides. All right, now here's a moment where I'm going to definitely pause and we're going to talk about this. I'm going to throw some parentheses around that d minus b right now. This is the hardest part for students, right? Over here we had 8x minus 5x and we were able to just say, hey, that's 3x, right? Because I'm just doing 8 minus 5, I'm getting 3, and then the x kind of comes along for the ride, if you will. So what do I do here, right? I have ax minus cx. Well, if you think about it, right, this is where we can factor the x out. Let me move this over here just to give myself some space. I'm going to have x times a minus c is equal to d minus b. Right, so I am literally using the distributive property, but in reverse. I'm factoring an x out of both of those two terms so that I'm left with this. Well, now remember, I've got something times x equals something, right? That something that's multiplying x is just a minus c. So I am now going to divide both sides by a minus c. Those cancel, and little extension of my page here, there we go. X will now be equal to d minus b divided by a minus c. All right, by the way, if you're now wondering why did he suddenly get to drop the parentheses in this line? Well, fractions almost by default have parentheses around their entire numerator and around their entire denominator. So those parentheses really don't have to be shown. The fraction groups the numerator and groups the denominator. In other words, if I was trying to figure out what that was equal to, I would have to do the d minus b first, I'd have to do the a minus c second, and then I'd have to do the division third. But that's it. And probably the hardest step in this problem, right, is really understanding what's going on here. But it really is what I did here, right? When I did 8x minus 5x, I got 8 minus 5 times x. That's exactly what I have here, right? ax minus cx is a minus c times x. I'm still just subtracting the coefficients, just like I did here. The big difference is here, when I did 8 minus 5, I was able to say 3. Here, when I did a minus c, the best I could do is say a minus c. Let's try a few more of these, because these definitely you need some practice on. No offense, right? Actually, we got one more of these, and it's a very practical example. Let's take a look at exercise number 6. The future value of an investment that is calculated with simple interest is given by the formula below. V equals P plus P times R times T, where V is the future value in dollars, P is the original amount invested, known as the principal, R is the yearly rate as a decimal, and T is the number of years investing. Rearrange this equation so that it's solved for P. Oof. Okay. Now you might think, well, that's going to be easy, right? I'll just take this stuff and I'll subtract it from both sides, and then that'll leave me with this P all by itself. The thing that's tricky here is that I've got a P, right, that shows up twice. I'm going to write this thing down a little bit larger so that we can talk about it a bit more. All right, I have V equals P plus P times R times T. All right. V equals P plus P times R times T. And I've got to get my P all by itself. And that's tricky because it's here and it's also here, and I can't combine those, right? I can't do that because this multiplication comes first. So I'm going to give you a little hint. I'm going to put a times 1 here. P times 1. That's not P dot 1, that's P times 1, right? So how do I isolate the P? Well, I pull a trick that is very similar to what I did before. What I'm going to do is I'm going to factor that P out, and that's going to be 1 plus R times T, right? That P is both multiplying the number 1 and it's multiplying the two variables R and T. Now, to get P all by itself, it's a piece of cake, right? You know, this is a very simple equation. It's actually a one-step equation at this point because I have something complicated, but whatever. I've got something multiplying P equals V. To get P by itself, I'm just going to divide both sides by 1 plus R times T. That cancels. And now P is equal to V divided by 1 plus R times T. And that's it. A little bit trickier maybe than the last one because it doesn't appear that this first P is multiplying anything. You know, if that was like P times A, then it might be obvious. Oh, I just got to factor a P out of both of them. Here it's a little bit harder because you have to really understand, oh, that's P times 1. So then I can factor a P out of both of these two terms, right? They're terms in this expression, okay? And then it's easy to isolate the P by dividing both sides by 1 plus R times T. All right, let's summarize this. We really didn't learn any new equation solving techniques today, right? Everything that we were doing primarily was just reversing the order of operations to isolate a variable. The big difference in today's lesson is that many of the times we had to leave calculations undone, if you will, because the calculations involved numbers that we didn't know. You know, A, B, C, D, etc. But as long as we feel comfortable with the steps that we're taking when we solve an equation, we can just leave it as, oh, all right, x equals b minus c divided by a, right? It's simple enough to do that. You'll get a lot of practice on this on your homework, and it will come up here and there throughout this course. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking, and keep solving problems.